Hello everyone. So welcome to the fifth session of Statistics for Data Scientists. So in previous sessions we talked about measure of central tendency. So today we are going to talk. Today we will discuss about the measure of variability. Okay. So in statistics, basically our goal is to measure the amount of variability. Okay. How variability for a particular set of scores, a distribution. Okay. How the data are distributed and what is the variation among the data points. So in simple terms, if the scores in distributions are all same, then there is no variability. Right. What does it means? If we have data points, suppose if we have 10 data points and the distance between each data point is same, so that means that there is no variability, there is no variation among the data points. Right. So this is what variability means. So measure of its variability, which is also known as measure of spread or measure of dispersion, basically it helps us in quantifying the extent to which the data points deviate from the central tendency. Right. They provide a valuable insights into the distribution of data points and how spread out they are from each other. Right. So yeah, so basically we have five different measures which are used for finding the variation within the data set and sometimes in comparison with even other population as well. Okay, so among these the first measure is range. Okay, so yeah, so before getting into range, see in general, a good measure of variability basically it serves two purposes. Okay, number one, variability it describes the distribution. Specifically, it tells whether the scores are clustered together or are spread out over a large distance. What does it mean? It means that whether the data points of a population or a sample they are concise, they are clustered, or they are spread out. They are spread out in the sense there is a variation. Right. This is purpose number one. Okay, it describes whether the data points are close together or they are spread out over a larger distance. Purpose number two is it also measures how well an individual score represents an entire distribution. Okay, so basically this aspect of variability is very important for inferential statistics, where relatively small samples are used to answer questions about the population that we have also already discussed in our inferential statistics. Like like a sample, basically we used to extract the characteristics of a population from the sample. Okay, and the variability it plays a very important role in finding out the characteristics. Okay, so in this chapter we will cover all these different measures: range, variance, standard deviation, interquartile range, and mean absolute deviation. Okay, see of out of all these measures, standard deviation is like it is the most used one. Okay, see, we have different implementation of all these measures at different places. Okay, it depends on situation. Like even interquartile range, it plays very important role. Okay, when we are exploring our data. Okay, so we will start with range. Okay, so basically, range is the basic measure of the spread of variability in a data set. Okay, range is nothing but it is the distance from the largest score to the smallest score in a distribution. Okay, suppose we have 10 data points. Okay, in that 10 data points, we have a value with we will be having a minimum value and we will be having a maximum value. Okay, so the range is nothing but it is the distance from the largest score to the smallest score. If the largest score is suppose 25 and the smallest score is 5, that means that the range value is 25 minus 5 and that is 20. Okay, so this is the range value. Now, see, the range is perhaps it is most obvious a way of describing how spread out scores are, how the data is spread. Okay, it simply finds the distance between the maximum and the minimum score. But the problem with using a range is like it is only determined by the two extreme values, minimum and maximum value, and it ignores all the data point within that, in between these two in these two extreme values. Okay, so this is the problem. It does not consider the data points apart from the extreme values. Okay, so yeah, let us consider one example. Okay, suppose we have two data sets, data set data set 1 and data set 2. Okay, so in data set 1 we will take some values: 45, 68, 51, 65, 57. Some more data points: 50, 55, 95, 48, and 51. Okay, now the mean, if you will calculate the mean of all these data points, we will be getting 59, and the median value is 53. Okay, let's take data set 2 points. Okay, we will take 5, 0, 75, 80, 97, and 42, 39, 38, 150, and 64. Now the mean in this case is again 59, and the median value is again 53. Okay. Now you can observe one thing. Okay, these two data sets, they have different data points, but again their mean and median values are same. Okay, so that means, see, these two data sets, it does have the same mean and median value, but the data points are entirely different. So that means that data set with having same shape and size can have same mean and median, but they are not always the same. Okay, now see, these are the very small data sets, and manually we observe the differences. But when we have a very large data set and enormous data points, in that case we need some better measure of observation. Interquartile range, it is the middle half of the data, and it measures how evenly the data is distributed across the average. Okay, so generally statistician, they prefer IQR over over range, because IQR is not influenced by outlier. Okay, it is used to measure the variability by data set into four equal quarters. What does it mean? Whatever, like, suppose we have a data points. Suppose, just a moment, let's open. Suppose within a population X, we have some certain number of data points. Okay, now data points will be distributed, right? Even if it is a normal distributed data or non-uniform distributed data. Okay, the entire distribution will be divided into four different quarters. Okay, this is the median. Okay, this is the median. Okay, and for a normally distributed data, mean, median, and mode will be same. Okay, this median, this will be our quarter two. Okay, and it is exactly divided into four different quarters. This is quarter one. Okay, that will be 25%. Then we have 26%, 25%, and this again is 22%. Basically, in the case of range, where to explain the variability or variation on the data point, we have just considered extreme value. Okay, but see, that is not a very efficient process of finding the variation, because in that case we are ignoring the other data points apart from the extreme value. But in interquartile range, we are not just considering the extreme value. However, we are ignoring them, and we are focusing on the middle 50% of the data. And we are trying to find out the variation or variability or spreadness within that. Okay, now see, the interquartile range, it ignores the extreme scores. Instead, it measures the range covered by the middle 50%. Right. Now, in any data points, okay, that will have an extreme value, right? Extreme value, this is the minimum value, and this is the maximum value. Okay, in between, the middle point will be our median. Okay, Middle point will be our median or the quarter 2. Now this portion will be our lower half. Okay, it will be our lower half. Okay, now in the median of minimum value and quarter 2, this will be our 25th percentile, or you can say that this is got Q1. Okay, and the median of quarter 2 and the maximum, this will be our 75th percentile, or we can call it Q3. Okay, median we know that this is the 50th percentile. Okay, now the Q3, the formula to find Q3 is, I mean IQR. IQR is nothing but the difference of Q3 minus Q1. This is the formula to find the IQR value. Okay, so now just let us take one example to understand IQR in a better way. Okay, suppose we will find out the IQR, and we will also check how can we find outlier with the help of IQR. Okay, now let me take one example. We have a suppose we have a data points 11, 12, 13, 14, 15, 16, 15, 16, 17, 18, 19, 19, and 20. Okay. Now there is a concept called five number summary. Okay, five number summary. Now this five number summary, it is nothing but the minimum value, the 25th percentile, the median, 75th percentile, and the maximum. This is called as the five number summary. Now, in order to find the IQR, first of all, we will learn the first is the minimum value. So the minimum value here is 11. Okay, and then 25th percentile. So 25th percentile will be 25th by 100, 25 by 100 into the formula into n plus 1. N is nothing but the number of data points. In this case, we have 12 data points. Okay, so this will become 25 by 100 into 13. Okay, so we will get around 3.25. Okay, and this point is nearby 3. Okay, so 25th percentile will be the third element among this data point. Okay, so the third element in this, the third item is that is 13. Okay, so 25th percentile is 13. Now we will find out the median value. We right now not quite. So 75th percentile. Again, the formula will be same, 25 by 100 into 13. Now this time we will get 9.75. Now this value is near to 10. Okay, so 10 in this case is 19. I think it is 19. Yes. So it 26 will be 90. Now the formula to find IQR is Q3 minus Q1, right? And Q3 value we know that it is 19 minus Q10, Q1 is 13. So we have 6. Our IQR value is 6. Now let us consider we have a outlier over here. Okay, so you can see that the standard deviation among all these data points, it is very normal. It is almost 1, right, among each data point. Suppose we got a new data point which is 68. Okay, now you can see that the standard deviation is very different, like it is quite high, right? So now in order to find out the outlier, what we'll do that we will find out the lower bracket. Okay, lower bracket is nothing but the lower half that I mentioned you. So the formula to find out the lower bracket value is Q1 minus 1.5 into IQR. Okay, so Q1 value is 13 as we found out, 1.5 into IQR value is 6. Okay, so 13 minus this will become 9. So the lower bracket value is 4. And upper bracket value, it is nothing but Q3 plus 1.5 into IQR. Okay. Now the Q3 value we have, it is I think 19, right? And then 1.5 into 6. 19 plus 9, this is 20. Now see, the lower bracket and the higher bracket, we got it. That the extreme values are, now the extreme values are, the minimum value is 4 and the the upper extreme value is 28. Okay, so all the data points that will fall in between these, we will accept those, and the data point which is outside this range will be our outlier. Now 68 is out of this range, right? In that case 68 will be outlier. Okay, that is an outlier. Just let us take one more example. Okay, we will take one more example where we'll try to find out the IQR. Okay, so I'm just considering these values: 6, 2, 1, 3, 5, 4, 7, 9, and 8. Okay, now so with respect to the five number statement, okay, the median in this case, median value will be the median value. Okay, it is nothing but the quarter two, right? So if you see, we have around 9 data points. Okay, 4 data points prior, 4 data points. So the median is nothing but 5. Okay, this is our median value. Now the lower half or the 25th percentile, or you can say that the quarter one. Okay, so this is our lower half, right? So lower half will nothing but we'll take the median of this one. So 2 plus 1, 3 by 2. Just if you want 5. And then the upper is to the 25th percentile or the Q3 value. In this case, this is our upper half. And then we'll take 7 plus 9, 2. So it will be 16 by 2, that is 8. Right. Now the IQR in this case will be Q3 minus Q1, that is 8, that is minus 1.5, that is 0.5. This is the IQR value. Right. Now we will take a look on our third measure of variability, that is variance. Okay, so you can see that in this case, okay, we are like, this is the area where we try to, like, most of our data points are concised, and okay, and we are considering this for finding the variability. So basically, variance is the average squared difference of the value from the mean. Okay, it measures how far each data point in the data set from the mean. Okay, in here, if you see so if you will see this value, okay, x here, the x bar is the mean of the population. Okay, and x is the data point. So basically, what we are trying to do over here is that we are trying to find out the distance of each data point from its mean. Okay, from its mean. Basically, what happened now? The variance, it provides a quantitative measure of the dispersion or spread of the data set around its mean, right? A larger variance indicates greater variability among the data points, while a smaller variance, it suggests more consistency or more uniformity. Now, variance is the square of the standard deviation. Okay. Another important measure of spread in statistics. This is after standard deviation. I say that variance one of the important measure for finding the variation. Right. Now, variance it also takes into account the difference between each data point and the mean, and this makes it very sensitive to the change in the data point. Right. Yeah. So basically, what I mean to say that it captures the deviation from the mean, providing valuable information about the dispersion of the data. However, whenever there will be a new points, whenever there will be a new data point in the sample, okay, so there could be larger variation, right? That is what it is sensitive to the change in the data set. Now, see, one of the very important application or use of variance is that when we perform hypothesis testing, okay, so we have a very huge implementation or very great use of variance because we are in basically in hypothesis testing, we try to find out the relationship between the groups, okay, or within the groups as well. And in that case, we try to find out the distance between each data points within the data set or between the groups of the same data set. Okay, so like if you see the ANOVA test, where like the analysis of variance, where we try to find out the variation within the same group or among the groups. What does it mean? Okay, it means that a larger variance, if the variance is large, that means that will indicate that the variability is great among the data points. And if the variance is low, that will represent that the variation among the data points are low or small. Understand? Okay, from the mean value. Okay, if you can see this formula, okay, xi is nothing but the data points. Okay, these are the data points, and x x bar, this is the mean value. Okay, so we are trying to find out the deviation from the mean value. Okay, so greater this value means the variation between the data points and the mean will be large, and smaller the value, the variation among the data points is low. Okay, fine. So, okay, so this is the formula to find out the variance for population, entire for population. However, however, if you have to find it for sample, okay, so the formula will be summation of data points minus squared by n minus 1. Now, okay, some of the important applications of variance, let me also clear that variance, okay, variance, it takes into account the difference between each data point and the mean. Okay, now what happens because of that, it is very sensitive, it becomes sensitive when the data changes. Okay, it captures deviation from the mean, now the providing valuable information about the dispersion of the data. Okay. Now this variance it is also quite helpful in hypothesis testing. Okay, basically in inferential statistics, variance plays a very important role in hypothesis and confidence interval estimation. Okay, like in ANOVA, where like analysis of variance is used to test the difference between the groups, within the groups and with the groups as well. Okay, so there we used to check what is the what is the relation with other variables. So mean absolute deviation, it is very important. It is one of the important measure of variability in statistics. Okay, and it has number of benefits over other measures. Okay, like unlike the variance and standard deviation, which are sensitive to extreme values, okay, outliers, but in absolute deviation, it is robust to outliers. Now, by considering the absolute difference between each data points and the mean absolute deviation, it provides more stable measure of dispersion. Okay, even in the presence of outliers, right? Because we are considering the absolute value of data point and the mean. We are not squaring it. Squaring it can like it will suppress the outlier value. Okay, but in mean absolute deviation, it is robust to outlier. The standard deviation, it is an average distance from the mean value, right? And standard deviation, it is a fundamental measure of variability in statistics, okay, that quantifies the dispersion of spread of a data set around its mean value. deviation, it provides a quantitative measure of how much individual data points deviate from the mean value. Okay, it shows that what is the distance of each data point from its mean value. Now, a larger standard deviation indicates that there is a larger distance between the mean and the data point. Okay, while a smaller standard deviation indicates a smaller distance between the mean and the data point. Now, smaller the distance, more concise the data will be and more uniform the data will be. However, the larger the standard deviation, more the non-uniformity and non like that the data will be non-concise. It will be not it will not be concise. Right. Now, standard deviation, it takes into account the difference between the data point and the mean. Right. And it makes and making it very sensitive to the change in the data set. Right. If there will be introduction of any new data set, there will be a rapid change in the standard deviation. Right. So it captures a deviation from the mean, providing more valuable information about the dispersion of the data. Now, in the context of normal distribution, the standard deviation is a key parameter which determines the shape and the spread of the distribution. It is used to define the width of the bell curve. Okay, width of the bell curve. It is the standard deviation. It is the standard deviation with the help of which this bell curve is formed. Okay, greater the standard deviation, lesser the standard deviation, better will be the curve of this bell shape distribution. Now, standard deviation, it also facilitates in comparing the analysis between data sets or groups. Like there are number of tests where we use this standard deviation, whether it is ANOVA test, or whether like even the hypothesis testing. Okay, we are using standard deviation to check the relationship within the groups and among the groups. Okay, so standard deviation has numerous applications. Okay, and the formula to find the standard deviation is it is the summation of uh, the data points and the mean value. Okay, by number of data points. Sorry. Okay, so yeah, let me show you an example also. Just a moment, we are about to finish now. Okay, so let us take an example. Okay, so we have a data points. Let's take some data points. 2, 6, 5, 3, 2, 3. Okay, so now the data points 2, 6, 5, 3, 2, 3. Okay, and the second is we have to find the difference between the data points and the mean. So the mean value will be 2 plus 6 plus 5 plus 3 plus 2 plus 3 by 3, 6. So this is going to become 90 by 6, I think. 21, it's not 19, it is 21. Okay, it is 21 by 6 and you will get 3.5. Okay, and okay, so the difference here is minus 16. So 2 minus 3.5 will become 1.5, 2.5, and then 1.5, then minus 0.5, minus 1.5, and then 0.5. Right? Then now the deviation will be, so this will become summation. If you will take the summation, okay, if you will take the summation, this will become 13.5. This negative value will goes off. So 13.5, right, number of data points we have 6, right? So for sample it is 6, and then this we are going to 2.25. This is our standard deviation. Okay. Now there is one more thing I would like to let you know, the empirical rule for standard deviation. Okay. So basically the empirical rule says that when we have normally distributed data, okay, when we have a normally distributed data, then 68% of the values will be fall within first first standard deviation from the mean value. Okay, let me show you over the graph itself. Okay, suppose this is the graph of the of a normally distributed data point, right? Now, empirical rule says that when for a normally distributed data point, 68% of the data will lies within the first standard deviation. Okay, so if this is the median value, okay, this is the median value, or we can also there this is quarter two or a median. Okay, now from this side to first deviation. Okay, to first deviation minus, and then we take it first plus. Okay, so now it says that 68% of the data for a normally distributed data, okay, 68% of data will be covered in first standard deviation itself. Okay, and then we have 95% of data will be covered in the second standard deviation. Okay, 95% of the data will be covered in second standard deviation. Okay, and in third is okay, and 99.7%. Okay, this is the third standard deviation. This is second standard deviation. Okay, this is second standard deviation, and for third standard deviation, almost 99.7% of the data will be covered. Okay, this is what empirical rule says. So this is all about the measure of variability. If you have any question, any doubt, please comment and please drop your message in the comment box, and we will reply back to your queries and questions. Please do subscribe to our channel for the entire statistics course. Okay, and then we will follow up with the machine learning and then deep learning neural networks, linear algebra, and then we'll jump into the visualization part. Everything we will be covering in this entire course of data science. Thank